Redix International would like to welcome you to our informational video series. This video provides an overview of converting a HIPAA-related X12 EDI file to a MySQL database via the use of the Redix Cloud. This video will utilize the HIPAA X12 5010 A1 837 Professional Healthcare Claims electronic format as its primary example. In order to utilize and mimic using this format, the user will need to have the proper rule defined in their user account. In lieu of this format, any other format from the Redix RMap series may be substituted. Before we begin, we should log into the secure Redix Cloud. From the public access page, redixwebservice.com, users may log into their private user area. For the purpose of this video, a demonstration account is used. The site uses a salt and hashtag system, so even Redix administrators do not have access to user passwords. In most cases, all data uploaded to the Redix Cloud is encrypted prior to upload, so although it seems as a perfectly functional system to the end user, Redix administrators do not have access to any confidential information. Only the client end user may view much of the material. Once logged in, the user is presented with a visual dashboard. The dashboard shows how much of their quota has been met, whether it be occurrences, uploads, or input files. In addition to quotas, the user may view any errors and login activities. The user may use the calendar control to select a date range. The site will remember your last selected choice so that some options, such as viewing the period of time since last sign-in, may be displayed by default. Prior to viewing this example, we should verify that our intended transaction type is set up in the system. To begin, we will navigate to the Define Conversion Rules setting area located under the My Account dropdown. A rule must be defined that has an 837p inbound, the 5010 A1 format, and is to be converted to database DB. Once this rule is present, we are ready to upload files. From the browser interface, a user may upload files via a dialog box or a drag and drop to the browser. For this example, we will upload 3 837p files. The files are then queued up in order of selection. This set of files was easy to keep in order, being that they have a common prefix and a sequence number. Once queued, the user may augment the list using the red, orange, or green buttons, allowing the user to upload individual files, cancel a pending upload, or halt an upload already in progress. The green button at the bottom of the screen allows me to upload all at once in the order selected. I will hit that button now. Note the progress of each file and how there may be a delay due to size. After the list is completely uploaded, we may immediately go to the tracking area. We can see the whole list of files that were just uploaded and their current status. Redix retains a full history of a file's existence on its system. A special red-colored pending or processing text is used for those files uploaded and waiting to complete processing. From the default tracking page, users may track the individual files and their outcome. This is done through the list of files and a series of possible icons. The user may click on the list icon. This list shows the history of the upload from analysis of transaction types and occurrences through its final process, whether that was validation, tracking, conversion, or even push to database. This list is very important to database users as additional delay may occur to load the database. A user may also click on the report icon. Most formats will have a default report. In the case of an 837 file, there is a balance report to show the financial amounts. For other formats, there may be a simple summary report for their respective occurrences. At all times, there is a Download Cloud icon. This icon will allow the user to download all files relevant to the file's upload. A zip file will download that contains the original input file, occurrence summary file, and all output files that Redix has, whether they are the default reports, summaries, or conversions. The zip file is conveniently organized by in and out folders. Now that we have seen an example of uploading and how we see the file level tracking, it is time to look a little more closely at where the uploaded 837p data ended up. Once the data has completed loading to the database, the tables may be viewed in the RMap database area. Users may restrict the data viewed by using the calendar control. Any column may have a filter applied. The primary purpose of this area is for debugging and eventually report generation. The actual database is very systematic in that it is integer key based and with a trickle-down order. Each RMap format has an RMP table. Table names are denoted by the last portion for the full name. On the RMP table, there is a key that acts as the import ID. Every table for the format will have this key linking each loaded file to its data. Likewise, each table that represents the start of a looping level, for example the IGM table, which exists for all RMap formats, has its own key. Each child and sibling table has a link to this looping level key. Users may note that all data in this database may be set up to mirror back to their own private database. Now that we have covered the load process for an RMap file, let's look at more advanced data tunneling. While the MySQL database in the Redix cloud displays the data in a very organized fashion and may have a few quick items for reporting, many may want to interface with the data in a much more complex manner. Cloud users may enable the RMap synchronization in the cloud and set up a mirroring system back on their local system. Here you can see the area where we are able to do this. Once enabled, users may download the configuration files and with a few minutes of setup, which include initiating the database on the client server and configuring the connections. Synchronization is ready to go. To view the synchronization in progress, a command window is opened and the monitor is started. Once started, the user will see the connection and startup calls, and then one should see the actual rows and batches in transit. This command window shows the startup of the client and any operations performed since, which may include the client catching up since it was last executed. Once the data is in the client database, users can perform many calls against the database. A simple exercise is to look at the individual tables. One such example is to view the 837 professional table. The database is called synced278req. We scroll down to the tables that have the prefix of T837P. The first should be the RMP table. If I select this table, I can see every individual 837 professional file that has been loaded. Redix offers several reference manuals, including this one from our website, which is located in our resource area. I can use the reverse lookup in our online reference area appendix to locate any item in our RMap. This includes the ever-popular 2300 loop CLM01, also known as Claim Submitter's ID. It tells me it is in the CL0 table, the first column, and sure enough, I can see it back in the table. So if I go and look at the actual table now, go to CL0 table, select the top, and indeed, the first column is the claim patient control number, which is one of the most important keys. Queries may be small or quite complex as the user has a full control over their staging tables. This would include any calls necessary to migrate the data to the client's other database system. There is much value to this data when a third-party report generator is applied. This video has briefly shown the Redix RMap conversion cloud solutions. While these cloud solutions offer many manual tools, all operations may be automated. To view these offerings, please review the video Redix Cloud Conversion Solutions. Should you require further assistance, please obtain our contact information from our website located at redix.com/contact. Thank you for your time.